Good evening. Tonight we're going to talk about Unit 2, Day 5, and we're going to work on solving proportions. To begin with, let's review what a ratio is. Now this you should know from middle school. A ratio is a comparison between two items. For example, taking a look at the pictures on this page, the ratio of blue circles to pink circles is 5 blue circles compared to 3 pink circles. Remember that we can write a ratio in one of three ways. We can write a ratio with the word 2. We can use, let me back up here. We can use the colon, or we can write it as a fraction. Now, what we're going to talk about in today's lesson is a proportion. And a proportion is an equation, so it's going to have the equal sign, that states that two ratios are equal. For example, 7 to 8 equals 42 to 48. That is a proportion. Two ratios, 7 to 8, 42 to 48. Now, when we work with ratios to determine whether the pairs of ratios are equivalent, we use the cross products. And the cross products are found by multiplying diagonals. So 7 times 48, one diagonal, 8 times 42, the other diagonal. Notice that when you multiply each of those, you get the same value. So since their cross products are equal, the ratios do form a proportion, and the pair of ratios are equivalent. Some properties of proportions is going to be helpful for us in this lesson. Number one, the reciprocal property. You can flip the ratios over. 2 to 3 equals 4 to 6. We can simply flip each ratio. That means that 3 to 2 is the same as 6 to 4. We can switch the means. That means the means being the ones on this diagonal. If A to B is the same as C to D, then A to C is the same as B to D. We simply switch the means. 2 to 3 is the same as 4 to 6. Well, I switch the 3 and the 4. And finally, we can add the same denominator to each side. If A to B equals C to D, then A plus B to B is the same as C plus D to D. Now, what we want to do today in dealing with equations is we want to be able to solve proportions. So take a look at our first example. 2 to 3 equals 6 to x, and we want to find this missing value of x. So what you want to do is you want to use your cross products. Again, those are the ones found by multiplying diagonal. 2 times x, 3 times 6. And then remember the cross product property says that if this is a proportion, those have to be equal. So 2x equals 18. We then simply divide by 2, and we figure out that x equals 9. You may have heard this before, it's talking about as cross multiply and divide, because that's what we did. But I want you guys to get used to setting up equations because they're not always going to be this simple. Take a look at a second example. Again, we cross multiply. In purple, 8 times n. In green, 5 times 4. 5 times 4 is 20. 8 times n is the 8n. Then we solve. 20 equals 8n, so we divide both sides by 8. They're actually showing it reduced down to the lowest terms. Because it's 20 over 8, we can pull out the factor of 4 from each one, and our answer is 5 over 2. Well, let's take a look at this example. Again, x to 15 is the same as 60 to 100. Cross multiply. X times 100, 15 times 60. X times 100 is 100x. 15 times 60 is 900. Think about this now. It's a nice one-step equation. We're taking 100 times x to get 900. So we solve this equation by dividing both sides. And what are we going to divide by? Well, what's the coefficient of x? That 100. And we figured out that x equals 9. Not bad so far, but the proportions are not always going to be this easy. Take a look at this example. Not only do we have just a single variable, we can also put that variable within an expression, but it's the same process. First step, cross multiply. 5 times 7, that's on one diagonal as you can see. Sorry about that. 2 times n plus 3. Well, notice when we take 2 times the n plus 3, we have to distribute, giving us 2n plus 6 equaling 35. We then have to solve, so it's a two-step equation this time. So what are we going to do? Well, we have to isolate the 2n part, so we'll subtract 6 on both sides. Then we'll divide both sides by 2, and 29 over 2. Just a little bit more challenge, but it's going to take us into those two-step equations. Notice in this example, we have variables in 2 spots, but we still do the same process. 4 times 27 minus 9, or n, excuse me, and 5 times n. So we have to distribute 108 minus 4n equals our 5n. Notice that the right side of this equation here only has n, so we're going to add the 4n to both sides to make it equivalent, leaving us with 108 because these would cancel out. 5n plus 4n is 9n. And then we'll divide both sides by 9, and we find out that n is 12. Another way that we're going to be using proportions is with similar figures. So let's define similar figures. Two figures are similar if their corresponding sides are proportional, could be equal, but not necessarily, and their corresponding angles. Similar figures have the same shape, but possibly different sizes. When we look at this, triangle ABC is similar to triangle DEF, and this symbol right here means similar to. The order of the letters is important. A matches up with D, B matches up with E, and C matches up with F. That means that angle A will have the same measure of angle D, angle B will have the same measure as E, and C will have the same as F. The order matters. We're going to use it to help us solve. Again, similar figures, remember, have the same shape, but are not necessarily the same size. The lengths of the corresponding sides are proportional to one another. I like this diagram because it uses colors. Notice that the yellow matches up with the yellow, the teal with the teal, and the green with the green. So let's look and see how we would solve this for x. So to find the missing length, the first thing we're going to do is we're going to write ourselves a proportion. 6, the yellow from the first triangle, matches up with 9 from the second, and 7 matches up with x. Now you're going to want to write these as a fraction, but I didn't have the ability to do that, so I wrote it with a colon. Step 2, cross multiply. Well, 6 to n, 7 to x, so I'm going to take my 6 times my x and my 9 times my 7. Again, if you've written this out as a fraction, it's going to be a whole lot easier to see. 6 times x is 6x, 9 times 7 is 63. How are we going to solve this equation? Well, we're going to divide everything by 6, because that's what x is. So we get 63 over 6. We reduce that down to lowest terms, always simplifying our fractions, 21 over 2. And that is our lesson on Unit 2, Day 5, using proportions and similar figures.